Okay, so we move on to the revenue. Okay, so in other words, we rename Y as total revenue, average revenue, or marginal revenue, and then we rename X as quantity. Okay, and then the focus is on finding the Q, the quantity that will maximize total revenue. Okay, just some basic concepts you already learned from first year economics that average revenue equals total revenue divided by quantity. Marginal revenue is the change of total revenue as a result of increasing output by 1 unit. So marginal revenue is actually the first order derivative of total revenue. And then at Q asterisk, let's say this is the critical point or critical quantity that maximizes total revenue. The first order derivative of total revenue, which is actually your marginal revenue, equals 0. Remember, slope is 0. Second order derivative of total revenue is negative. Remember, concave or the unhappy face. And then there are some questions on the slides, so I would rather want to focus on the questions on the study guide. So I will do one question here. Okay, this one, chapter 3, question 1. This is the total revenue. Let me have everything on one page. Total revenue is minus 50Q squared plus 500Q. 1.1 is easy. Marginal revenue is the first order derivative of total revenue. And then 1.2, the intention is to give you easy marks just to do substitution. When Q equals 2, then marginal revenue, just substitute 2Q equals 2 into the marginal revenue equation, then you get 300. Okay, the focus is 1.3, okay? At which quantity is total revenue maximized, okay? At this critical point, the first order derivative or the slope of total revenue equals 0, okay? Which is minus 100Q plus 500 gives you 0. And then you move the terms around, then you find out the critical Q, which is 5. But you need to check the second order conditions to ensure it is a maximum turning point. So the second order derivative it means you differentiate the first order derivative one more time. It gives you minus 100, which is negative. So indeed, when Q equals to 5, total revenue is maximized. And then the last question 1.4, again, the intention is to give you easy marks. So you already know this is the critical quantity or the maximum turning point, Q equals to 5, then you substitute it back into the total revenue equation to find out the maximum total revenue, which is 1250 when Q equals 5. And then I show you the graphical sketch, even though it is not asked. Okay. So the revenue type question or the maximization of total revenue is quite straightforward. I would rather want to move on to short run production where we assume labor is the variable input, but capital is fixed. Okay, so this is total product, it's a function of labor. So in other words, we rename X as labor and we rename Y as the production quantity, either total product, average product, or marginal product of labor. Average product you learn from first years, it is total product divided by labor quantity. Marginal product means the increase of total product as a result of employing one more unit of labor. So marginal product is actually change of total product divided by change of labor. It actually means first order derivative of total product. Okay, and then, okay, when we want to find out the labor quantity that maximizes the marginal product, this is the first order condition. Remember, slope is 0. Second order condition must be negative. Remember the unhappy face, concave. And then the same when we move on to average product. At which labor quantity is average product maximized? This is the first order condition and then the second order condition. And then finally, when we want to look for the labor quantity that will maximize total product, this is the first order condition. Slope must be 0. So remember, I remind you one more time, first order derivative of total product is actually marginal product. And then second order conditions. And you should remember the law of diminishing marginal returns. Marginal product would reach its maximum first, followed by average product, and finally total product. And I'm going to prove it, okay, with a question. I'm not going to go through the questions on the slides because I already provide very detailed explanation. So I would rather want to do chapter 3. Question 6. This is the total product. Okay. And then I ask you to derive first order and second order derivative of total product. Easy. Okay. And then at critical point, I want to find out the labor quantity that maximize total product. So at the critical point, isn't the slope equals 0? This is why you have 0 on the right-hand side. First order derivative equals 0. Then you do a bit of factorization. Then you have two critical points when labor is 0 or labor is 25, but we have to check second order condition. So we substitute each L quantity into the second order derivative equation. And when labor is 0, second order derivative is positive, it means convex. So this is not what we want. But rather when labor is 25, second order derivative is negative. Then it means maximum turning point because the shape is concave. Remember the unhappy smile. So total product is maximized when labor is 25. Then I just substitute this labor quantity back into my total product equation. Then this is the maximum total product. Okay, so keep in mind when labor is 25, total product is maximized. Okay, next one. Marginal product is actually the first order derivative of total product. Okay, now I want to look for the labor quantity that maximizes marginal product. So at this critical point, the slope or the first order derivative of marginal product is 0. So it means 1,125 minus 90L. So I take the first order derivative of marginal product. 0. Then labor is 12.5. Then I need to make sure that indeed it is maximum turning point. So I have to derive the second order derivative. You will get minus 90. Indeed negative. So it means when labor is 12.5, marginal product is maximized. Then the last thing I have to do is to substitute this labor quantity 12.5 into the marginal product equation. Then I would know my maximum marginal product amount. Last one, average product. You first have to derive the average product equation, which is total product divided by labor. Then it actually means there is one L gone. So yeah, because remember total product is average product is total product divided by labor. Let's go back to 6.4. At the critical point, first order derivative of average product is 0. So you differentiate this function, then you get this. Then you move the terms around, you get 18.75. And we have to check the second order conditions, minus 30. So indeed, when labor is 18.75, average product is maximized. Then the last thing you have to do is to substitute this labor quantity to find out the maximum average product. And then I provide a graphical sketch, and I already proved the law of diminishing marginal returns because marginal product is maximized first when labor is 12.5, isn't it? Let me just check. Yeah, 12.5. When labor is 12.5, marginal product is maximized, followed by average product. Average product is maximized when labor is 18.75. And then total product is the last one that is maximized when labor is 25. So I have proved the law of diminishing marginal returns. Okay. Then the next one, cost. Okay, these are the basic cost concept you should know. Okay, the total cost concepts and average cost concept. Marginal cost is the one you need to know. It is actually the first order derivative of total cost. And for this module, we would focus on the minimization, and then the focus is on the first two actually. So let me focus on the first two. When marginal cost is minimized, the first order derivative of marginal cost, which is the slope, is 0. And then the second order derivative of marginal cost, which gives you information on the shape, is positive, the happy face, happy smile, convex, so minimum turning point. And then when average variable cost is minimized, you must first derive average variable cost equation, which is total variable cost divided by quantity. Okay, when AVC is minimized, first order derivative 0, second order derivative positive. Okay, and marginal cost will be minimized first, followed by AVC, and then finally average total cost, which we won't cover in this bootcamp. Okay, and then there are examples on the slides, but I don't want to waste time on these examples. They are very comprehensive, so I rather want to do one question. Okay, question 10. Okay, This is total cost. Okay, so where is my marginal cost? Yes. So marginal cost is actually the first order derivative of total cost. So isn't it? This 300 falls away, then you have 40 minus 16q plus 2q squared, isn't it? Yeah. Yes, so this is my marginal cost. And then average variable cost is total variable cost divided by q. So it means in each term, this is my total variable cost. We must take out the fixed cost at 300. So this is my total variable cost. And then divided by q, it means in each term we have a q falls away. This is why your average variable cost gives you 40 minus 8q plus 2 over 3q squared. And then we need to work out the quantity that minimize marginal cost. Okay, so first order derivative of the slope is 0, and then q is 4. Then we check second order condition, indeed positive. So minimum turning point. Okay, so keep in mind when q is 4, marginal cost is minimized. And then we work out the next one. Average variable cost, first order derivative of the slope is 0 at the turning point. So q is 6 after you do some mathematical calculations, and then we check the second order conditions, 4 over 3, positive. So indeed, when q is 6, average variable cost is minimized. So this is the graphical sketch. So I prove that marginal cost is minimized first before AVC is minimized. Okay. And then the last one, the last economic application of differential calculus is profit maximization. You have two methods. The first one, derive marginal revenue and derive marginal cost. Remember the condition you learned from first year's economics, where marginal revenue equals marginal cost. Profit is definitely maximized. For this method, the advantage is that you don't need to check any second order conditions. Second method, you first derive the profit equation, which is total revenue minus total cost. And then you look for the first and second order conditions, okay? When profit is maximized, first order derivative is 0. Second order derivative is negative. Okay, and there are a lot of questions, examples on the slides, which I won't go through because the explanation is already very detailed on the slides. So I would rather do this question, chapter 3, question 11. You have total revenue and total cost. This is why I can easily derive marginal revenue, 25. Marginal cost, 20 plus 0.05q. Then I apply the first method. Marginal revenue equals marginal cost. Then I move the terms around. Then quantity is 100. Okay, so when q is 100, total revenue is maximized. Then 11.4, I move on with the second method. I first derive the profit equation, which is total revenue minus total cost. You just have to be careful. Total cost for this subtraction, when you remove the brackets in connection with total cost, these signs will change actually. This is why you see the change from plus to minus here, and the same for the other one. Then this is my total profit equation minus this one, my total profit equation. And then I have to now apply the second method. First order derivative is 0, or slope is 0 at the critical point. So this is my first order derivative, 0.05q plus 5. Then you move the terms around. Don't you notice? Once again, I derive the same profit maximizing quantity as in the first method. Q is 100. But I need to check the second order condition, so I derive the second order derivative, which is minus 0.05. Okay, negative indeed. So indeed, profit is maximized at this critical quantity, which is 100. Okay, and then there are lots of examples on the study guide, self-explanatory. Just one thing you need to remember is that when it comes to questions in connection with perfect competition, you must keep in mind that price is the same as marginal revenue. So for this question, I give you the price, 3 Rand. This is why marginal revenue is the same as price, 3 Rand. And then the last thing is there is a nice summary table actually coming from the prescribed chapters on the first and second order conditions for maximizations of revenue, maximization of the total product, average product and marginal product, minimization of the cost. Remember, we focus on marginal cost and average variable cost minimization. And finally, profit maximization. Second method, you need first and second order conditions. First method is easy. Marginal revenue equals marginal cost. So that's it for the second mass eco topic.